Hi everybody, we're going to take up these booklets, and the first booklet I posted 2 days ago was what is a series circuit, or maybe I posted before the weekend, I can't remember, but so we did all the current electricity, what is a circuit, what are the components of a circuit. Now this one is what is a series circuit, and the next one is what's a parallel circuit. So there are two different types of circuits. For example, a circuit you see on the street when like all the lights on the street, they come together, all on or all off, or like Christmas lights, they all come together, they're all off together. And then we have other types of circuits, just like your house. You go to the bedroom, you turn the lights on. It's not like your entire house is going to go on. You go to the bathroom, you turn the lights off. It's not like the whole house goes off. So we're just going to learn about these two circuits. The first circuit is called series circuit, and it's a circuit that has only one path. So the key for it is that one path, one way for electricity to travel. There's no other options for electricity, just one way to travel. So main things we have to know is that there's only one path. So remember that, okay? And then the other thing is that all off or all on. So all off, if you turn off everything will go off together, and everything will go on together, okay? The electrical devices or appliances also share. That's the $100 I was telling you that each one will get $50, right? So, and also if you add more light bulb, you get less light, right? So I'm just going to take up, and this is what you see here. That's a series circuit. That means electricity has to go through light bulb 1, go to bulb 2, and then come back. There's no other option. No other way. One way. This way, and then come back. So in this circuit, electricity has only one path. The circuit is complete. What does the electricity have to go before it reaches bulb number 1? It has to go here first. So bulb number 1. Number 1. If bulb number 1 were to go out, that means to go off, so no light, then bulb number 2 will go off too. So if this one gets killed, that means no way for electricity to travel. So this will go off too. If this one goes off, this one will also be off, okay? So no matter what, if something happens to this one won't work. Something happens to this one won't work, okay? If you add more light bulbs, means they have to share more. So if this is $100, of electricity, it will be 50 and 50. And if I have another light bulb here, then it will be 33, 33, 33. They have to share. Okay, so if you add, each bulb will give off less light. Now, if I take all of these out and just simply take this one out and just have one bulb, therefore all the 100 goes here. And if I have 100, then I get more light. So if you add, you get less light. If you take away, you get more light. It's all about sharing. If you have $100 and you have 5 friends, you each get 20. But if you have to share your $100 with just one friend, each one will get 50. Okay, it's the same thing. So this is fill in the blanks. The circuit you're learning about here is a series circuit. In a series circuit, electrons have only one path to follow. In a series circuit, when one appliance is off, all other appliances will go off. In a series circuit, when one appliance is switched on, all other appliances must be switched on. So it's all about all off or all on. You can't have one light off, one light on. In a series circuit, the appliances share. Sharing means if you have 100, each will get 50 if there's two. Okay? In a series circuit, when you add more appliances, each one will get less power, less. Home, factories, and schools are not wired like that. Can you imagine? You go to your home and your dad, is in the washroom, turn off the lights, and then the whole house go off. Or one teacher in the school turn off one light, the entire school goes off. So that's not a good way to wire your school. Electric current comes from moving electrons. Moving. So hard to write with a mouse. Okay. Charged atoms that are not moving, electricity that's not moving, it's called static electricity. Static. Moving electricity is called electric current, current electricity. Series circuit, one path. One path. Minus terminal, that's for the battery, is the starting point where the electricity starts. And plus terminal, when the electricity comes back, it's an ending point. Okay. If you look at these pictures, these are all series circuits, so there's all one path. Sometimes switches open, the path is not working, but it's still all of them built one path. Now, how do I draw a series circuit with symbols? I have to create only one path. So the first one says one dry cell, one open switch, right? Two motors, make sure you practice because your test, your unit tests, I ask you to draw and send me a picture of what you have done. Okay, so be prepared to be able to draw what I ask you. Two dry cells, so one closed switch, and three light bulbs. 1, 2, 3. So you can see there's only one path. If I start here, there's only one way for me to go back. One way. Okay? Next one dry cell, no switch, and three loads. So I'm just going to draw an appliance, that's one load. I'm going to draw a light bulb, that's another load. And then I can draw a motor, that's another load. Remember, loads are anything that use electricity. So any of these symbols, that's a load. So your choice. That's one load, that's another load, that's another load. Two dry cells, open switch, one motor, and two light bulbs. Okay. So if I ask you on the test, draw a series circuit for me, it has to look like this. One loop only, one way. I start here, there's only one way to go back. So one rectangle, one. Okay? The next booklet, we are going to do is called parallel circuit. And that's a circuit you use in your house because the toaster is on, the microwave is on. You know, your kettle is on, your toaster is off. So you can have more than one path. More than one path. Now, what are the things important about parallel circuit? Is that they have more than one path. 2 ways to go back to the battery. 3 ways to go back. 5 ways. And you can use or shut off one appliance at a time. One at a time. In a parallel circuit, we don't share. So $100 coming from the battery, each one gets $100. But they have to share the current, which is not here, okay? If you add more load, does not change anything, does not make it weaken, okay? Still works with the full power, full power. You add more, you take away more, nothing affects. So it does not make anything give less light. It's the same amount of love. And it's perfect for home, school, factories. Okay, let's take up this booklet. So if you look at this, look at the pattern. Here's the electricity coming. That's one way, right? Or electricity, well, I'm just gonna skip this light bulb and I go this way, right? So you can see there are 2 separate ways for electricity to travel. 2 ways. How many bulbs are in this? How many bulbs are in this circuit? There are 2. How many paths? There are 2. Is the circuit complete? Yes. Even though I have no switch, everything is connected. Okay? Does the bulb light up? Yes, they do. Okay? So they are not showing you because they don't want to have to give you the answer. But yes, they do light up. Does the electricity have to go through bulb number 1 for bulb number 2 to light up? No. They're 2 separate paths. If the bulb number 2 to blow out, bulb number 1 stay lit. Stay lit means on. You still give light. It doesn't matter. If this one dies, so what? The green one works. If this one dies, so what? The yellow one works. Okay? So you can have separate paths. I'm just going to erase that. Okay? So if bulb number 1 still stay lit. If a third bulb is added, you still give the same amount of light. The bulb in this circuit, they do not share. So if there's 100 here, it's not going to be 50-50. It will be 100 and 100. Your home is wired in parallel circuit. Series won't work. I don't want to go to the bathroom and turn off the light and my whole house go off. I don't like that. Parallel, 1 room at a time. 1 appliance at a time. So home, schools, factories, everything are not wired in series. Your school is wired in parallel. In a series circuit, electricity has only 1 path. In a parallel circuit, more than 1 path. In a series circuit, when one light goes out, the other one goes off too. They both have to work together. In parallel, 1 off, the other one can stay on. Extra bulb in a series circuit gives less light. Extra bulb in a parallel circuit gives the same amount of light. In a parallel circuit, you can shut off 1 appliance at a time. In series circuit, you cannot. Either all go off together or all on together. Parallel circuit, loads work 1 at a time. 1 at a time. Series circuit, loads work together. Another bulb added to a parallel circuit does not change the amount of light. It stays the same. Another bulb added to series circuit, it does change. It does change. You get less light. So here in this picture, what do we get? A series circuit. There's only one way, series. How many paths? One. How many loads? Two. Is the circuit complete? Yes, because the switch is closed. Are the loads working? They should, even though picture is not showing, because the switch is closed, there will be light. If one bulb to blow out, the other one will go off. That's how a series circuit is. Another bulb, if you add, it will make the other two give off less light. This is not a good way to wire your home. If you look at this picture, this is parallel. One way to go this, and then another way to go this way. Okay, so two ways. What kind of circuit is this? This is a parallel circuit. How many loads does this one have? Two. How many paths? Two. Complete? Yes, it's a complete circuit because switch is closed. Now the question number 13 belongs to the other one. Are the loads working? Yes, because the switch was closed. Is one go off in a parallel circuit, the other one will give up the same amount of light. Adding, I will get the same amount of light. In a parallel circuit, doesn't matter if you add or remove light bulb, you get the same amount of light. Is that a good way to wire your house? Yes, a parallel is always a good way. This picture is with symbols. Again, this is one loop, one. So this is a series circuit. One path, series. How many paths do you have? One. How many loads? Two. Now I'm just not going to write the full name, but light bulb and motor, right? You can see a motor and light bulb. It's hard for me to write, so light bulb and motor, two. Is the circuit complete or incomplete? It's incomplete because the switch is open. The switch is open, therefore incomplete. Are the loads working? Nope, because the switch is open. Is this the way you wire your home? Nope, don't like that. I don't want one all go off together or on together. If you look at this picture now, do you see how there are more than one path? I could go this way and come back, or I could go this way and come back. So there are more than one way, right? What kind of circuit is this then? It's a parallel circuit. How many paths do I have? Two. How many loads? Two again. Name them. It's motor and light bulb. How many switches does this one have? Two switches. Is the appliances working? Okay, I'm just going to erase this so you can see. Which one is working? This one will work because the switch is closed. This one is open. It's not going to work. So which appliance is working? Motor. Which one is not working? Light bulb. Is your home wired this way? Yes. Okay. Now look at this one. This is now four ways, guys. You have to count like that. 1, 2, 3, and 4. So don't count the lines, count the different pathways. Because if you sometimes get confused, you say, oh, one way, two ways, three ways, four ways, five ways. No. It's all about how many ways you can go and come back to the battery. So there's four ways. What kind of circuit is this? This is a parallel circuit. How many paths do I have? 4. How many loads? 4. You have 2 motors, and then you have 2 light bulbs. So I'm not writing the full thing. How many switches? 4. Are the loads working? Which ones are working? This one is working and this one is working. What are they? The light bulbs. So the light bulbs are working because the switches are closed. Which one's not working? The motors, because the switches are open. Is your school wired this way? Absolutely, yes. Now let's just put a check mark. This is a summary. Only one path for electricity to follow, that will be a series circuit. More than one path for electricity to follow, parallel. Loads work or shut off one at a time, that's parallel. All on or all off is series. Appliances share, that's series circuit. They share the voltage. They share the $100. Do not share, parallel. Good way to wire a home, parallel. Not a good way to wire a home, series. Extra bulb will give it less light, series. Does not change the amount of light, parallel. Okay, so that's a summary of this table. So just going to do this one again. Open switch, close switch, 1 dry cell, 2 dry cell, wire, motor is like a big circle, and then light bulb is a loopy thing. I'll do it one more time. Don't like that one. Okay. So here, true, false. A dry cell gives static electricity. False. Batteries don't do that. Static electricity lights our home. Not doing that. Burns our home. Static electricity causes lightning. True. A safe place to stay during lightning from storm is under a tree. That's false. You will burn with the tree, so don't do that. Electricity is useful. Absolutely. Can you imagine living without it? Electricity can be dangerous. Very true. The school is wired in parallel. True. Your home is wired in series. False. A parallel circuit lets you shut off one appliances at a time. Very true. Appliances wired in parallel share the electrical pressure. In parallel, they don't share, so that's false. Only in series they share. So last page, we're just going to draw these circuits, but these are going to be what they're asking me. The first one, they're asking me complete series circuit means the switch has to be closed. Every time I hear complete means the switch has to be closed. So even though it says one switch here, I have to know that it's closed because it says complete. And then one battery. Battery means more than one dry cell. And then 3 light bulbs. Okay, so this is closed. And when the switch is closed, means my circuit is complete. That means I will have light. Okay, this one says complete parallel circuit with one switch. Okay, again, my switch is going to be closed. But the way you draw, you will, actually I want to draw one again. So here's my battery, 1, 2, okay, here's my switch, closed, and then it's a parallel circuit, right? So I have to put my motors in different path. So here's one motor, here's another motor, here's another one. So every time you have parallel, you have to create more than one path. So each one goes in a separate line, okay? This one, incomplete parallel circuit, 2 switches and 1 light bulb and 1. So I'm just gonna draw my battery, okay? So 2 switches, incomplete means the switch is open, okay? So I put my 1 light bulb here. Okay, I don't like this switch too long. So switch open, and then I have to create another pathway for motor because this is a parallel circuit. And another switch, which is open. So you can see it's incomplete circuit. Motor has a switch open, light bulb has a switch open. So the circuit is incomplete. Incomplete means open. So if I give you on a test, draw an open circuit, that means you have to remember open or incomplete means the switch has to be open. Because if switch is closed, I will have a complete circuit. So my circuit is working. Okay, I think this is the end.